Hello students, today we are covering 7.5 on scale drawings. Follow along with me on page 300 in your textbook. Our key idea that I would like you to write down is on scale drawings and models. A scale drawing is a proportional two-dimensional drawing of an object. A scale model is a proportional three-dimensional model of an object. Scale is the measurement in a drawing and model that is proportional to the measurement of the actual object. The scale gives the ratio that compares the measurements of the drawing or model with the actual measurements. So if 1 inch is the drawing distance, the actual distance is 10 miles. So we have the drawing compared to the actual. Please pause the video to write this down. So for example 1, on page 300, it says, what is the actual distance between the city of Cadillac and Detroit? And here you will see a scale factor. It shows 1 centimeter is equivalent to 50 miles. So when I have my ruler, if you have a ruler at home that measures centimeters, I suggest you use it. If not, you can trace the one in the book. I line up my ruler so that here's Cadillac here, and here's Detroit, and I'm going to measure the distance, and I get 3.5 centimeters. So I have 1 centimeter is equivalent to 50 miles, which is equal to 3.5 centimeters in the actual map distance. Now I need to find D, which represents the actual distance in real life. I can use cross product since 1 times D is D, and 50 times 3.5 equals 175. And since I'm comparing centimeters to miles, this is B, 175 miles is the distance in real life. I'd like you to try on your own to find the difference between Traverse City, which is here, and the city of Marquette, which is here. Now, if you don't have a ruler that measures in centimeters, you can create your own by tracing this scale factor in your book, and then go ahead and measure the distance. Example 2 is finding a distance in a model. So here we have a model of the Earth. It says the liquid outer core of Earth is 2,300 kilometers thick. A scale model of the layers of Earth has a scale of 1 inch to every 500 kilometers. How thick is the liquid outer core of the model? So we use our scale 1 inch for every 500 kilometers. Okay. And we know the Earth is 2,300 kilometers thick. So we keep kilometers on the denominator since it's inches compared to denominator or to kilometers. But we don't know how many inches this is, so you can call it X. Now to solve, you can use the cross product, or in this case, it might be easier to isolate the variable X. If it's being divided by 2,300, multiply both sides by 2,300 kilometers. And you'll notice the kilometers cancel out with the kilometers. Whatever I do to one side, you should do to the other. So multiply it by 2,300 kilometers. Now here the units kilometers cancel out with the kilometers. So when I multiply, I get 2,300 over 500 equals X. And when I simplify that and divide, I get 4.6. And it's in inches, since X is in inches. 4.6 inches is the total distance. We have another vocabulary word. It's scale factor. When the units are the same, the scale can be written without the units. So I'm going to show you that in example 3. For now, I would like you to try on your own example 2 on page 301. The mantle of Earth is 2,900 kilometers thick. How thick is the mantle of the model? So use the scale and go off of what you know to solve. Example 3 is finding a scale factor, and this is found on page 301. A scale model of Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model? So the model is only 10 inches tall. It's very short. They're small. But in real life, it's 100 feet. Now, the scale factor of this model, when I reduce it, is 1 inch for every 10 feet. All I do is write an equivalent fraction by reducing it. Now it says, what is the scale factor of the model? Well, we need to write the scale with the same units. So since I'm comparing inches to feet, pardon the bell. Since I'm comparing inches to feet, I know there are 12 inches in 1 foot. So instead of 1 inch for every 10 feet, I'm going to change this and I'm going to multiply by 12. So I know it is 1 for every 120, since 1 foot equals 12 inches. Sorry, that's a little sloppy there. 1 foot equals 12 inches. So if I multiply it times 12, 10 times 12 is 120. And the inches cancel out. So the scale factor can also be written as this, 1 to 120. Now try on your own. Number 3, a drawing has a scale of 1 millimeter to 20 centimeters. What is the scale factor of the drawing? Use the fact that 10 millimeters is equal to 1 centimeter. Now, example 4 is finding the perimeter and the area on page 302. The scale drawing of a computer chip helps you see the individual components on the chip. Now, a chip is normally only 2 millimeters, which is extremely small. This drawing is actually 1 centimeter. So the drawing is actually larger than it is in real life. We need to find the perimeter and the area of the computer chip in the scale drawing. So looking in our book, if you have a ruler, please measure it. When I measure the side length, I get 4 centimeters. So when I find the perimeter, I just add up 4 plus 4 plus 4 plus 4, which equals 16 total centimeters, as you see here. To find the area, you multiply length times width. So 4 centimeters times 4 centimeters is 16 square centimeters. So that's the total area. Now, this is of the scale drawing. Now, for B, we need to find the actual perimeter and area of the computer chip. So remember, the computer chip is 1 centimeter for every 2 millimeters. When I measured it, it was 4 centimeters. So now I'm trying to solve for X, or the actual size. So to solve, I can see that 1 times 4 is 4. So I'm just going to use equivalent fractions. 2 times 4 is 8. So X is equal to 8. Keep the units the same in the denominator, which are millimeters. So if now the actual chip is 8 millimeters, the perimeter is where you add up all 4 sides. 8 plus 8 plus 8 plus 8 is the same thing as 4 times 8, which equals 32 millimeters. For the area, I know it's length times width, so it's 8 times 8, which is equal to 64, and it's millimeters squared. Now for C, you can compare the ratios of drawing the perimeter to the actual drawing. So in the drawing, the perimeter was 16, and in the actual real life, it's 32. So 16 over 32 is 1/2. In the drawing was 16, and then it changed to 64. Now, there is one part that we need to consider, and we have to use the fact that 1 centimeter is really equal to 10 millimeters. So we need to get this in common terms. Pardon the bell once again. So if you look at example C in your book, I would like you to copy it down from C because we are running out of time. So pause the video, finish going over the example, and we'll complete it in class. For your exit ticket today, use the scale factor of 1 inch to 8 feet and complete the chart here. This is your inches, this is your feet. Set up the proportion 1 over 8 equals the next fraction you see here. I hope you have a great day, and I'll see you in class tomorrow. Bye-bye.